Like you notice section 6 was easier, the volume was easier than some of the surface area for most people. We're going to kind of coast our way to the finish a little bit. Doesn't necessarily mean it's easy, but compared to what we were doing, it's going to be quite a bit easier. So I'm going to try to do this drawing at the bottom that'll kind of help with it. But what we're looking at in this section is if we do scale factors, if we take and change the size of something, how does that impact the volume of the object? So I'm going to try to do the drawing. You're welcome to kind of try to draw it like I'm trying to draw it. My drawing is going to be kind of hokey probably, and we'll see if you can do better than me or not. But if we were to take and say double this thing, so this object has a certain volume, yes, a certain amount of space inside it. If I were to take and try to make that twice as long, so maybe something like this here, and I don't know if it's worth trying to draw as well. You're welcome to give it a shot. But if I were to make it twice as long, but not any higher, not any deeper, how does its volume compare to that original black box we had there? Double. So in this case, my scale factor was a 2. It doesn't always have to be a 2. It could be like 0.5 or 0.8 or 17 times bigger or something. But you at least take the original volume and we just multiply it by the scale factor. That if my scale factor was a 2, the volume is going to be twice as big. Fair enough?
Hold on.
Cool. If I were to take and change this thing in 2 dimensions, though, so let's say I'm not only making it twice as wide, but I'm going to make it twice as deep. It's going to go back twice as far. So then I'd have my twice as wide, but I also go back twice as far. And again, you don't have to draw this. For me, I just like, a lot of people just go and memorize the equations, but I like being able to kind of see what's going on. It helps me remember something more long term. But if I would take and make this thing twice as long and twice as wide, so going from this black one to include this whole part we have drawn now. Volume just got how many times bigger?
3.
Ooh.
4.
We added 3 to it, but it's 4 times bigger. Fair enough? Because this was the original. I have to multiply that by 4 because I have 1, 2, 3, kind of 4 of those blocks. So how do I take my 2 over here and change it to a 4? Nice, square it. So then you could say, if it's changed in 2 dimensions, it's volume times the scale factor squared. Any guesses for this last one? Cubed, yep. So it'll be volume times scale factor cubed. And if you wanted to try to draw it, you could take and make all of them, that same amount higher. And again, I don't know if it's worth drawing, but at least then you kind of see it. So, and here we have that, and this, and this. As my brother would say, even a blind squirrel finds a nut once in a while. Kind of you got lucky. But I started with 1, over here. I kind of have this 1 in the front. And we have next to it 2. Behind it we have 3 and 4, and 5 and 6 and 7 and 8. So now I have 8 of those blocks all stacked up, which would be a 2 to the 3rd. And I just put a 2 there. But 2 to the 3rd, 2 times 2 times 2 is 8. But are you a believer? At least enough?
Hold on. It makes
Cool.
sense.
Cool. And that works for multipliers other than 2 as well. So if it's half as big in 3 dimensions, you're going to get something like that. So you may see a question something like this one here. What's the scale change and in how many directions? So the scale factor, we made it how much bigger?
Twice.
Nice. So scale factor equals 2. Because we started with a 3, so I should have maybe said I'm starting with this like red cube here. So we start with that. Started with a 3, became a 6. 3 times 2 gives me 6. Or you could say 4 times 2 gives you the 8. Or 2 times 2 gives you the 4. But you guys okay with scale factor 4? Or scale factor 2, rather? And we changed it how many directions?
All 3.
Yep. In all 3 directions. If it had only been 1 or 2 directions, it would have looked kind of like the part way through when we did this drawing up above. The one direction was just that one. 2 directions was those 4 on the bottom, and so on. We okay for those? And the notes are done, but I want to write down 2 comments, and I maybe should have included them in the outline, but this is at least going to help make more sense. So you could go back and squeeze these on the bottom of the first page if you wanted to, but so the scale factor, or I'm going to put a SF in parentheses. That's how I started abbreviating it. But if you're trying to look at what's the scale factor, what did something get multiplied by, What you could do is take the new length. A lot of times you'll be able to look at it like that last one and just say, hey, look, it's twice as long. All the numbers are twice as big. But if you can't figure it out from just looking at it, take the new length and divide it by the original length. And that's helpful if your scale factor is maybe like 0.8 or something like that. You can't just look at and necessarily do in your head. The other thing, and I don't know if this is worth writing or not, I'm going to write it down, but the book sometimes in the questions will say the scale factor is 5. But they don't tell you is it 1 dimensions or 2 dimensions or in all 3 dimensions. Which way did they make it 5 bigger? So I would just say assume the scale factor is in all 3 directions. So assume the size change, the scale change rather, is in all 3 directions unless you're told differently. So if they were to say something undergoes a scale change of 3, then assume it's 3 in all 3 directions, unless they say a scale change of 3 in 2 dimensions. That's it for the section.